Hi there, this is Penelope. This is a video on looking at how we can use substitution in integration for some products and some quotients. Consider this type of problem. Here the x term out the front isn't the derivative of the 3x plus 1 inside the bracket, so it's not quite like the previous ones that we've been looking at with substitution. Let's still use substitution of what's in the brackets though and see where it gets us. So let's say u is equal to 3x plus 1, and that'll give us our dx. So it's a third of du. Now let's see if that works. Let's put it all in. No, it doesn't work because we've still got an x term there. But what if we rearrange u equals 3x plus 1? Because we can extract x from that. Okay, now what we can do is instead of x, we can write a third of u minus 1. So the whole integral becomes u minus 1 over 3, that's our x, times u squared over the 3 from the derivative there. Now everything's in terms of u, it all matches up. So I'm just going to multiply out my brackets first. So u times u squared is u cubed over 9 minus u squared over also 9. Now I'm going to integrate because now it's nice and easy, and I get u to the 4 over 9 times 4 minus u to the 3 over 9 times 3, and put back in the substitution that we made right at the start. And we're finished. It worked. This one's a bit harder. We can use this idea of integration by substitution to integrate some quotients. Previous one was a product. The appropriate substitution is often not immediately obvious, but sometimes you just got to try and make a substitution for maybe the more complicated one and see how it works. So let's go for root x plus 1. So let's say let x equal root x, u plus 1. So that's a bit nasty to differentiate to find the dx. So let's square that. And that then will give us, it will give us two things. It will give us that x is equal to u squared minus 1, and also straight away it will give us what we're looking for, the dx term. Okay, let's see what happens. So we've got the integral of x minus 1 over square root of x plus 1 dx, putting in everything we've got. So x minus 1 becomes u squared minus 1 over u, because u is the square root of x plus 1, times dx, which is 2u du. Now that's really nice because the u's cancel and I can tidy it up. U squared minus 1 times that 2 would be u squared minus 2, and that's very easy to integrate. Even if I take out my bracket, it's even easier. So that's the integral, if I do that, will be 2u cubed over 3 minus 4u plus c. Substituting back, I could have actually said another way of doing that would be to take out a common factor of 2u over 3 if I wanted to. Could have done it that way. I'll finish this way first, so then that's 2 times x plus 1. Now u was the square root of it. I'm cubing the square root, so it'd be 3 over 2 over 3 minus 4 root x plus 1 plus c. Or if I was using the or way of writing it, I could have gone that the integral was equal to 2 times root x plus 1 times x plus 1 minus 6 all over 3, which tidied up gives us the same thing, 2 root x plus 1 x minus 5 over 3 plus c, which, believe it or not, is the same as what we've got over there.